This is This Week in Science and Education, Episode 25, Electromagnetic Radiation. Time for This Week in Science and Education, the show that talks about all things related to science, academic discovery, and health research, how to take that information and bring it into today's classroom. On today's show, Dr. Frank Prato from the University of Western Ontario and Appleby College from Oakville. All that today and more on This Week in Science and Education. This Week in Science and Education is brought to you by Polycom, world leaders in unified communications. Polycom.ca. And by Mueller Systems. Need a backup? Check out Mueller at MULLERDATA.com/VROC. Hey everybody, it's time for This Week in Science and Education. This is your host, Kevin Cougler. Joining me as always, Colin Jagoe from the Kawartha Pine Ridge District School Board. Hey Colin, how are you?
Hello and good afternoon everybody, great to be here.
Well, it's good to have you here, and as usual, Thomas Merritt has decided to join us from Laurentian. How are things up at Laurentian, Thomas?
You know, you'll be surprised to hear they're freaking cold up here.
I'm sorry to hear that. We're enjoying, what was it, plus 25, I think it was today, Frank? Is that right?
You're a funny man. It's a beautiful day up here. It's gorgeous, but it's chilly, I got to tell you.
Yeah, as long as you're driving, right, in a heated car, no problem. So joining us today, we have a couple special guests, and I'll introduce the gentleman to my right, your left first. This is Dr. Frank Prato. Frank is from the University of Western Ontario and the, is it the Lawson Health Research Institute? Yeah. So Frank is going to talk to us today a little bit about his research, and joining us in that discussion, we're very pleased to acknowledge Appleby College from Oakville, Ontario. Appleby, maybe you could just give a wave to everybody. How are you? Good. Excellent. So we have some grade 12 students there, and Dr. Actually, I'm not sure if it's Dr., but Anjali Ahuja, this is her class, and we'll ask them to introduce themselves in a minute as well. But before I get to you, Appleby, Dr. Frank Prato from University of Western Ontario, can you tell us a little bit about who you are, your research, and just give the students an idea of what it is that you do?
Sure. I'm very pleased to be here, and let's see, maybe I can introduce myself in a couple of ways. First of all, I don't usually wear sunglasses indoors, so maybe I'll explain that first. In 1982, I was extremely proud of the fact that my lab produced the first magnetic resonance image of a human brain. We were diagnosing a minor stroke at that point in time, and so we were the first to do that in December 1982. Now, why do I bring that up? I bring that up because since the end of December, I've developed a sensitivity to light, and so I'm wearing these sunglasses. I'll take them off so you can see that there are eyes behind here. But let me tell you, last week, they couldn't find out what was wrong with my eyes, so I guess about 30 years after the fact, 29 years after the fact, they stuck me in an MRI and looked at my brain. So as I explained to a colleague right afterwards, well, I don't have a tumor, I don't have an aneurysm, I don't have MS, I don't have a stroke, but I still can't see. And he said to me, well, 4 out of 5 isn't bad, Frank. So I got involved and interested in non-ionizing electromagnetic radiation when we were introducing MRI in the early 1980s. I'm also very pleased to be here for a number of other reasons. One reason is that I was this morning, I'll just tell you a little bit about my day. This morning I had an opportunity to meet with the gastroenterologists, both surgeons and medical people at the hospital, because we had just developed a new imaging technique to image irritable bowel. And we had done 6 volunteers, and we were trying to get the surgeons and the physicians to start referring patients to us. So that was the morning. Unfortunately, it started earlier than I'd liked, so maybe I would be wearing glasses anyways. It started at 7 o'clock in the morning, and I'm not very much awake at 7 in the morning. Then later in the day, I picked up a journal. I like reading science. this is, as you know, a well-known journal. And actually, there's an editorial in here about education in science, technology, engineering, and mathematics. And it says at present only 6% of all 24-year-old Americans, it's about the U.S., but it applies to us, hold an undergraduate degree in science, technology, engineering, and mathematics disciplines. And this is the fastest growing segment of the economy, and the Americans are being outstripped in terms of training people. And I'm very pleased to be here. If in any way I can influence you to continue on your interest in science, then extremely important for the economic health of our country. Now, as I said, I was particularly interested in the potential that non-ionizing electromagnetic radiation, in which cell phones are part of that process, as is wireless communication. But back in 1982, there was no such stuff as cell phones and wireless communication, but we were imaging like people's brains using magnetic fields and radio waves and extremely low frequency pulsed magnetic fields. And I got interested in the potential that there could be effects. Now, there was at that time a reaction to me getting involved because people didn't want us to find any effects of magnetic fields in biological systems. They wanted to first establish the role of magnetic resonance imaging in the facilities that we have for non-invasively diagnosing disease. But nevertheless, we persisted, and we now have a group in our lab that is internationally known for its investigations into non-ionizing effects of electromagnetic radiation. So right now I have a group of about 100. I'm going to be 65-year-old soon, and we're applying imaging techniques, and we want to look at diagnosis of disease, and I'm particularly interested in whether any of these things have effects. Now, recently, I was also in the last 10 years brought into this question of cell phone and whether there are cell phone effects. And so I'll leave it with a couple of quotes, and then you can start asking questions. In the Scientific American let's see if I can read it with these glasses on. This was which issue?
October 2010.
Thank you very much, Kevin. So October 2010, there was an issue called The Skeptic, and it summarizes at the end in terms of is it possible that cell phones can cause cancer, in particular brain cancer, because we put the cell phones usually against our heads. And the article makes fun of anybody who should imagine doing any research in this area. And I'll quote, if I can, I'll change glasses here. You'll see my eyes for a few seconds. This, although in principle it is difficult to prove a negative, in this case, one can say it is impossible for cell phones to hurt the brain. And so that's how it ends. Now, this morning I was trying to think of a similar quote, and I remembered something that Lord Kelvin had said about 100 years earlier. He said, there is nothing new to be discovered. This is before Einstein. This is before quantum mechanics. There is nothing new to be discovered in physics now. All that remains is more and more precise measurement. And to put in perspective another of his quotes, X-rays will prove to be a hoax. So why did I bring these two quotes together? Well, I assume that the imaginative class, grade 12 class at Appleton, will be able to ask me questions about that. And I apologize, the light's bothering me. Hopefully one of the imaging techniques I'm scheduled for later on this week will solve this problem as to what's wrong with my eyes. But in the meantime, I've got to have to put on some sunglasses. So that's the introduction to myself.
Super. Well, we're talking with Dr. Frank Prato from the University of Western Ontario, and I think at this point we'll introduce Appleby College, and I'll ask Ms. Ahuja to do the honors of introducing herself in the class, and perhaps we can take some questions from the students if you're game.
That's why I'm here.
I think we'll ask you to move closer to the microphone if you could. If you could move a little closer to the microphone, please.
Now can you hear me?
Yeah. Oh, that's much better. Thank you.
Great. So I have my grade 12 students here who have taken AP Physics, a number of other AP courses as well. And they are also enrolled in my science club, and they want to do some research and learn from Dr. Prato how electromagnetic radiations affect, or whether they do affect, the brain cell tissues. So they have some questions, and they would be looking for information and some maybe ideas how they can go forward with this research work. So that's what we are looking for here. So I will first start with Brent Ward, who's sitting on my left, and he will start with the first question. So Brent, you want to start?
Hi, Dr. Prato, can you hear me?
Yes, I can.
You can, okay. So my name is Brent Parker, and I'll be asking the first question today. So here we go. Is there any known link between electromagnetic radiation and brain function? And if there is, what is not known about the link between brain function and cognition?
I think we missed the last part of that question, Brent. Your voice kind of tailed off.
Okay. So is there any link between the amylase and the brain function? And what is not known, if there is in fact a link? Is there anything that's not 100% sure about?
Were you able to catch that?
I apologize. I'm not exactly sure what you asked. I think what you asked was, is there anything known in terms of effects of, would you say, cell phones on brain function? Was that the question?
Well, any electromagnetic radiation whatsoever. But yeah, cell phones would count as one, yeah.
What Brent is asking, is there any known interaction or relationship between EM waves and the brain? And specifically, he also would like to know what is not known yet, because that can be more scary than what we already know about. So is there anything that we don't know about and we should be looking for that?
Well,
Is that better?
It's an interesting way of posing a very difficult question. So, there have been a number of committees worldwide, and we have a committee in Canada that sets safety code limits, safety code 6, for example. And since 1999, a group of us have been getting together and reviewing the literature of what's known and what isn't known and what should be done. And we've reviewed the literature repeatedly about every 2 or 3 years. First of all, as I tried to indicate from the quotes I've read, we're probably in the same position we were 100 years ago in terms of what we think we know. There are those of us who think we know everything, and those of us who think we know very little. I mean, in astronomy, they're talking about why the universe is accelerating in its expansion, and they're talking about things we know nothing about, like dark energy and dark matter. So I put it to you that at this point in time, we're at a crossroads in terms of going forward. There seems to be a classical group of individuals who believe classical physics and even quantum physics, particularly quantum physics, who say there's no way that cell phone radiation can have effects. But we certainly know that cell phone radiation could increase temperatures a little bit. And the question is, can it do anything else? So there have been some very good studies looking at electrical activity in the brain, electroencephalography studies, and a fair number of them show that some of the waves between 8 and 12 hertz, seem to be affected by exposure to cell phone type radiation. So that's one thing. The problem has been to try to relate that to a behavioral outcome or a physiological outcome. So although we've been able to measure that there are some changes, and there's some controversy about this, the problem has been trying to nail down what this means, if anything. And the other issue is these experiments are all acute experiments. They're done over a short period of time, and we are being exposed repeatedly every day for long periods of time. So there is an outstanding group in Zurich, Switzerland, who have been looking at the possibility that changing brainwaves by electromagnetic radiation from cell phones is affecting sleep patterns, onset of sleep, different stages of sleep, and they seem to be showing things that have been reproducible. So I think we were at a very early time in understanding what's going on, and we must remember that just because there are effects, there may not be effects that are detrimental to health. In other words, coming over here, I almost froze myself walking over to this building, but that doesn't mean that exercise was bad to me. It might actually have been good for me. So we are at a cusp in trying to understand what's going on, and we face a lot of people, including the reports that I've helped to write, which suggests that there are no effects. As well, I happened to be a visiting professor in Sweden for a week in last May, and that group there have been studying whether waves from cell phones can affect the permeability of the blood-brain barrier. And they've shown effects at least 25 years ago, and they've repeated this stuff now, and they continue to show effects, although most of the scientific community are questioning them. Most of the scientific community have trouble reproducing them, but in looking at these effects, they seem to be real. So I think we face a time in our history where we have to look and say, let's try to understand and do the best possible science we can and the best possible research we can, and put the economic and political agenda aside when we're scientists. Otherwise, we're going to be doing the same thing that we accused the Russians and Soviet Union to do during Lysenkoism many years ago. So that's a long answer to your question. There's a lot known, there's a lot unknown, and it just takes imaginative young minds like yours to ask questions and then see if it's been explored in the literature, and then propose experiments that can be done to test a hypothesis. So I think this is a very exciting time, because if electromagnetic waves do affect biological systems, then there's a huge opportunity for beneficial effects in controlling these waves, just as there's a huge opportunity in the invention of magnetic resonance imaging to find out whether I have a tumor, an aneurysm, have MS, have a stroke, etc., etc. So believe me, if we can harness this, you know, there's always a yin and a yang, right? Nuclear power versus nuclear bombs, steel for plows, steels for swords, etc., etc. So I'm going on too much here. I'll wait for the next question.
Brent, does that answer your question?
Yes, it does. Thank you very much.
Thank you for the question. Go to Colin or Thomas for a quick comment, if they would, and then back to Appleby for another question.
Well, okay, I hesitate to ask a question in case the students had this one in mind, but Frank, you mentioned possibly controlling the waves. Is that something you can talk about? Can we look at how you would, if the issue is the cell phone, the radiation coming out of the cell phone, do we know ways that we can limit that?
Well, so the question is, what are the characteristics, or what are the features of the waves that have potentially biological effects? So, you know, initially cell phones were running at around 900 megahertz. They were analog phones, and now we have digital phones, and they're running at higher frequencies. So the question would be whether when we modulate these carrier frequencies in the gigahertz range, you know, it's unlikely, it seems, that such high frequencies, which are on for, you know, nanoseconds, could have effects on parts of the body, whether it's a chemical reaction, whatever. But the question always is whether the low frequency modulation, for example, phones these days are modulated about 217 hertz. When you're getting to those kinds of frequencies, you're starting to talk about the kinds of frequencies the human body communicates with. So, as I said, the electroencephalogram tells us that the electrical activities in the brain are, you know, between 0, 1, 2 hertz up to about 100 hertz. The question has been, is there a way of demodulating, of extracting the low frequencies associated with these very high frequency carriers? And the scientific community is split on this at this point in time, and there is no good information as to how the body could possibly do that. However, the ear does it with respect to sound. In other words, you can get individuals, and you can take a 1,000 hertz signal, which is a sound you can hear, and you can modulate that at 100 hertz, and people with trained ears can pick up that 100 hertz signal. Other people say, well, you can't do that because if you do a Fourier transform on this signal, it gives you the 1,000 hertz signal and the plus or minus and 1,100 hertz and 900 hertz. So demodulation is an area of research which is poorly funded at this point in time, but it will be important. So I believe that the possibilities exist, outside of frank heating. So I'm talking about non-heating effects where the research is up and down and all over the place. In the non-heating effects, where we're talking about frequencies, the question would be whether the biological systems can extract meaningful signal from the very high frequency carrier that is associated with cell phones.
We're talking with
Great,
Dr. Frank Prato from the University of Western Ontario. Appleby College, let's go back to you. I'm sure you have another question for us. And after you ask your question, if I could just get you to mute your microphone while Dr. Prato gives his response, that would be great. Thanks.
So Graham Mutter will be asking the next question now. He'll introduce himself and then he'll ask the question.
Hi, Dr. Prato. I'm Graham Mutter, senior too. I was just wondering, we're specifically interested in cancer, so if you could explain to us what a brain tumor is and how it pertains to cancer.
Sure. First of all, again, you'll hear the conservative literature. I can be non-conservative now because I'm almost 65, and if they fire me, they're going to have to give me a huge severance. So I'm trying now. By the way, I'm at a research institute, so I don't have tenure. I don't have university protection. I'm not part of a union or faculty. But regardless of that, I'm making a bit of a joke. I want to be as honest as I possibly can be. So the scare is cancer. Always the scare is cancer. So when the atomic bombs were dropped in Hiroshima and Nagasaki, we know that it takes 10 years to peak leukemias and 20 to 30 years to peak solid tumors. My father died at the age of 37, probably as a result of being exposed. He died of acute myelogenous leukemia, probably by being exposed to working in a factory that had been painting radium on aircraft dials during the First World War. So this is an important issue. Now the problem is latency times. With respect to ionizing radiation, the latency times for solid tumors, as I said, is 20 or 30 years. So risks has increased as we've continued to follow people from Hiroshima and Nagasaki. Now, in terms of cell phones, should there be a lag period? We don't know, because we're assuming that there probably isn't any cancer. If you look at this Scientific American article, it says physics tells you there can't be anything, right? Well, that's because they're looking at the possibility of producing cancer from a non-ionizing radiation using the same motifs, using the same comparisons or the technology or the concepts that were used for ionizing radiation. So, ionizing radiation causes cancer by damaging DNA, and there's not enough energy in a photon of electromagnetic cell phone to, strip an electron from a nucleus or cause a single strand break of the DNA, never mind a double strand break of DNA. But this is a very naive, Calvinistic type approach. I mean, what about other potential mechanisms? I mean, yeah, cancer can be initiated by DNA damage, but cancer has to be promoted. Just because the DNA is damaged, is it going to be repaired? Is it possible that radiofrequency fields will affect the repair mechanism and not, is it possible that, for example, when I told you about the group in Sweden showing increases in blood-brain barrier permeability, we have a blood-brain barrier for a reason, and that is to keep a lot of toxic material that gets into our blood out of our brain. If there's a small increase in the blood-brain barrier permeability, and toxins are therefore allowed to get into the brain, which has nothing to do with electromagnetic fields affecting DNA, but electromagnetic fields allowing material to get into the brain. And some of this material can, over 30, 40 years, increase toxins in the brain, a very small leak, hard to measure on an acute basis. Sure, that could cause an increase in cancer. Now, give you an example. The Interphone study came out. Now, this was a huge study. Involved all of Europe, and Canada participated as well. And this was a study to look at various forms of brain cancer associated with tumors. So it took a long time for the authors to finally agree on the text and the words for this to come out. So, and we had Canadians involved. We had outstanding Canadians, epidemiologists involved in this study. And so if you talk to some of the authors, that one of the senior authors thinks that there is a bias in the data, and there could be an increased incidence of cancer. Some of the other authors, that person was from Spain, the other authors from the Karolinska Institute argue that there is no bias in the data, etc. Now, the problem with epidemiology studies are that they're very crude. In other words, for epidemiology studies to convince us that smoking causes an increase in an increase in cancer, required a lot of epidemiology studies to finally convince people, and in the end we were talking about an increase in a factor of 10 in lung cancer. If you talk about exposure to asbestosis, epidemiology told us that there was an increase of about 20 or 100. Those things were easy to find. Epidemiology studies don't work if the risk is below 0.5. In other words, if there's a 50% increase in cancers due to cell phones, we won't see them using epidemiology studies. So the question is going to be open. It's going to be open a long time, and society has to decide whether there's an unknown question. It could be completely safe. I mean, the studies suggest that, while there's some debate between the senior authors, the world-famous epidemiologists are debating whether there's more there or not there. There have been a couple of studies which show that non-malignant tumors, sorry, I'm trying to remember the name, they're acoustic neuromas. Acoustic neuromas, there is a group from Sweden showed increases in acoustic neuromas. These are non-malignant tumors, or tumors that probably have to be removed, but they don't spread, they don't metastasize. And so there's been some debate, and some people have come down very hard on these authors and given them a very difficult time to further publish their work. But again, brought another article today. Let me see if I can find it. It is published in this journal, the Bioelectromagnetics Journal, and it's a title of a study here, a case study of mobile phone use and acoustic neuroma risk in Japan, and if my eyes will allow me. However, at the very last sentence, however, we could not conclude that the increased risk was entirely explicable by these biases, leaving open the possibility that mobile phone use increased the risk of acoustic neuromas. And this came out, you're going to help me with the date here.
February 2011, very recent.
So, again, I'm trying to open up the question to your imaginative minds. I'm saying we don't know. Science is only going to allow us to know to a certain level of certainty, because I said epidemiology studies are only going to tell us a 50% increase. I mean, power line, do you know how much research has been done to see if 60 and 50 hertz increase childhood leukemias? Huge amount of work. Still, the World Health Organization labels electromagnetic fields above a certain intensity, above 0.2, 0.3 microtesla, 60 hertz and 50 hertz, as a class 2B carcinogen. So, again, 30 years of work, putting all the data together, outstanding epidemiologists from the institute that gives out the Nobel Prizes in Sweden, from the World Health Organization, and still we are faced with these uncertainties which cannot be solved in easy ways. We need imaginative ways in the laboratory to solve them. Now, when you are asking as to whether we can have beneficial effects, and Dr. Merritt asked that question, just let you say that we've been experimenting with low frequency fields less than 300 hertz, not at 4 or 2 gigahertz, and we certainly can reduce pain sensitivity to about equivalent dose of a moderate dose of morphine, and we've patented that stuff, of course, and we are trying to get it to be used in patients. So the nice thing about RF is if we can demodulate it, then there's some real significant opportunities for benefit to humans. So it's the yin and the yang again. No matter what we invent, there's going to be those groups who are concerned about it, concerned about crossing the road, and those groups who say, what the heck, let's find out what's going on here. And you young people are going to replace me. I'm going to be 65 soon. You're going to replace me and start asking those questions.
Student at Appleby College, I'm sorry I didn't quite catch your name that asked that question. That answer your...
Yeah, it did.
Super. Well, thank you for the question. Colin, I'll let you chime in here if you have a quick question on anything you've heard so far or a comment.
You know what? Excuse me. It's kind of interesting because I'm sitting here thinking about what Dr. Prato was saying, and it really strikes me the nature of science, right? It's sort of in a big picture kind of way that we're always trying to find answers, but there's always that level of uncertainty that we can never say for sure. We can never prove anything, and somebody mentioned earlier about trying to prove a negative, right? If there's no effects, it's very hard to prove that there's nothing, right? and we're finding some effects, and they may be small, but they may be there, and because they seem to be small at this point, or because we don't have a mechanism yet by which we can explain the effects that might be there, it makes it very hard to say with any certainty, for sure. And the general public, and me and you and the students there, we want to know an answer, and there is no specific answer that we can give with 100% certainty. It just strikes me that it's really interesting, and in terms of scientific literacy, understanding that is really, really important. Now, just because we say we don't know doesn't mean that what you then say on the other side that you know any more certainly than we do. So it's that scientific literacy and critical thinking piece that I've been thinking about. It's very, very interesting.
We're talking with Dr. Frank Prato from the University of Western Ontario, and our special guests of honor, students at Appleby College in Oakville. Appleby, next question, if you will. You'll need to, yep.
Alisa Divani.
Hi there, my name is Alisa. Just to go along with Graham's question, we were wondering what the known changes in cells were that occur in them, which could result in a brain tumor.
Did you catch that? Sorry, could you repeat the question again?
Sure. We were just, along with Graham's question, we were wondering what the known changes that occur in cells were that results in brain tumors.
So what are the known changes that occur in cells that result in brain tumors, I think is what we heard? Okay.
Yeah.
Yes, so I don't know the answer to that question. I had a lab working for about 20 years looking at cellular effects. Let me say this. You're asking a question like, what causes cancer? And here in London, Ontario, and across the province and across the world, we have a lot of researchers working on cancer. I could be flip and say, if we knew what caused cancer, we would be treating people so that we would cure all of them and not just some of them. So now you're asking a very difficult question. You're asking me what's happening in the cell that could be generating a detrimental effect, which is that word cancer. If you ask me, what might open the blood-brain barrier to allow toxic material to go from the blood into the brain, I might have some ideas. If you're going to ask me what possibly could be changing the electrical activity in the brain when we're exposed to cell phones, which are turned on and off at about 217 hertz, I might have some answers. But if you ask a general question like, what am I going to, what's happening in the cell specifically that could cause cancer, it's a very, very difficult question. But there are a number of possibilities. One is that let's assume that we can't damage the DNA directly, and so that there is not necessarily any damage that is done directly to the DNA. But DNA is by exposure. But DNA is constantly being damaged. Single strand breaks are constantly being repaired and repaired very efficiently. So let's assume that there's a possibility that electromagnetic radiation is reducing the efficiency of single strand breaks. So that's one possibility, but it has not been proven. Let's assume that there are other things that might be occurring. Let's assume that to upregulate that cancer has to be promoted. In other words, not only do you have to have DNA damage, but you have to have cellular events that go on to turn on genes which shouldn't be turned on, have been damaged, and they go on. So the possibility is that electromagnetic fields could affect the promotion of DNA damage to generate cancer cells. There are other possibilities that have been published. The possibility that cells which are programmed to kill themselves if something goes wrong with their DNA, something called apoptosis, which I'm sure you're familiar with now. It's a common word in the literature. It's possible, and there's been some evidence that apoptosis could be delayed. And so cells which normally kill themselves because they don't want to become cancer cells, they don't want to promote a colony of cells going on to become cancer, that they self-destroy themselves. And the possibility is that apoptosis And that process, and that chemical process, is not happening as soon as it should happen to destroy cells that have abnormal DNA. So there's a number of points that one could look at. You could also look at ion exchange across cells. Our lab and a number of other labs have looked at the possibility that the calcium signaling across cells, you probably know that the concentration of calcium outside of cells is about 10,000 times higher than the calcium concentration inside cells. So the possibility exists that there's a perturbation of this calcium balance caused by membrane effects of electromagnetic radiation from cell phones. I don't know if I can say much more, really.
Tough question, I guess, but I think you did a great job answering. Appleby, does that answer your question?
Thank you.
Okay, super. We've been rolling right along here with these questions and wonderful answers from Dr. Prato, but I have been remiss in doing our sponsor spot, so I think we'll take a short 2-minute break while I talk about our sponsor and come back and take some more great questions from Appleby. So I do want to talk about Mueller Systems. They are a sponsor from Woodstock, Ontario. They are the makers of backup software and expertise to help you recover and back up all of your data in case of catastrophic events. So if you have some data out there that you don't want to lose, you need to keep protected, we do encourage you to try Mueller's. They not only help you find the data on your system to back up, but they will actually test it for you after you get the backup set up to make sure that it's working. If you go to the website right now today, you will be able to download and install and try their software 90 days absolutely free of charge. And that website address is muellerdata.com/VROC. That's MULLERDATA.com/VROC. We thank Mueller's for their support. And let's get back to the show. We've got a great show going here with some wonderful questions from Appleby College. Appleby, I'll let you ask another question, and then Thomas will let you comment as well after Dr. Prato gives his answer. Appleby.
We'll be asking another question now.
Hi, my name is Ashish Ghosh, and my question originally was a follow-up to what effects on the cell would radiation have. But under the light of the information that Dr. Prato now gave us, I have a slightly different question. First, I would like to start off by saying we have been in contact with someone who's actually running a synchrotron facility. I believe it's the Canadian Light Source synchrotron. As a high school student, I'm not really sure where figures would put it, but it has 2.9 giga-electron volts of energy and a 171 meter circumference. So I'm not much of an expert at synchrotron, so hopefully that might put in context for what we might have the opportunity to work with. So one of our focuses is trying to figure out the effect of electromagnetic waves on various types of tissues. Now, in response to the answer we received for the last question, we were wondering, is there any way to go about measuring the effect of radiation on certain types of tissues? Is that possible? And if there isn't any real concrete or known change in the cell, is there any other way for us to measure that and make a conclusion based off that information? For example, we're also considering taking a look at not only brain cells, but perhaps various different types of plants.
Okay.
Okay, so this is an interesting question. Unfortunately, the communication is such, and my old ears are such that I'm not sure I got it all. So let's make sure I understand the question. So first of all, you talked about the Canadian Light Source and the 2.9 giga electron volt circle that the electrons circulate in, and the synchrotron radiation that it produces. So I want to know, and that synchrotron radiation is usually in the ionizing radiation portion of the spectrum. So I don't understand the relationship between the Canadian Light Source and your questions regarding non-ionizing radiation. And I'm sure it's clear. I just didn't catch it. Could you just explain that part to me?
Well, our idea initially for our research project was to hopefully use the radiation that we could create using the synchrotron on various kinds of tissue, like such as plant tissues, brain tissues, like real variety. So we could hopefully see a spectrum of results. So what we were wondering is, would that radiation actually create any notable effect on these type of tissues, and would there be any way for us to measure that and perhaps make a solid conclusion based on that?
Okay, so you've done some work in the Canadian light source, and I'm impressed, very impressed. I'll tell you why I'm very impressed. I went to have my first tour of the Canadian light source 2 weeks ago, so I'm impressed that you know so much about it. As you know, it has a part of the project there to look at biological effects and use the monoenergetic X-rays to produce images of animals, cells, plants. Now, my understanding is that most of the radiation, or the radiation coming from the synchrotron, is higher energy, and I would like you to correct me, is higher energy than we are talking about in terms of cell phone radiation. So if you were talking about the effects of ionizing radiation on cells and stuff like that, then clearly, but maybe I'm wrong. I'm trying to remember. There was a facility for doing terahertz, I think, terahertz radiation. So okay, so so how would I use the radiation to see if there are effects on from cell phone? It's an interesting question, a very interesting question. It depends on the assay you might use. So again, I'm going to turn this back to you. Give me more information. What type of experiment would you like to do? Would you like to expose the cells in a petri dish to cell phone type radiation and use synchrotron radiation to measure the effect?
Actually, Tracy Walker, Mrs. Tracy Walker from the synchrotron facilities here with us. Actually, she's typing in and she's listening right now. And she is the one who will be supporting us, if possible, if we could go there. But actually, the question that Ashish wanted to ask, and I think I will ask again, is we will not be using the facility to use the radiation to see the effects, but actually use the facility to analyze the effects that we see. So if we could do something at the school, maybe have plants in different places where they could be affected by electromagnetic radiation, and then take those plants and maybe take out the tissues to be analyzed at the Canadian light source. So we will not be using the Canadian light source for the radiation effects, but there to analyze the effects that happen here at the school, or maybe in a laboratory.
Okay, so
that is the idea.
Sorry for not understanding the question. I apologize. So
no, actually, yeah.
So yeah, there's lots of opportunity. The Canadian light source has an opportunity in the biological part of it to do some very high resolution imaging of plants and animals. If you wanted to radiate plants and look at the ultrastructural effect, that would be one possibility. There are other very sophisticated things you could do with the monochromatic X-rays, which cannot be done in any other facility. For example, you could program cells with foreign genes, and you could look and see whether these genes were turned on. For example, one of the hypotheses in terms of what happens to cells when exposed to cell phone radiation is the possibility that heat shock proteins are upregulated. So you could program cells that when heat shock proteins are upregulated, they would increase the concentration of iron within the cells, and using the K edge of iron, which is about 28 keV, you could look and see in a very sensitive way, perhaps the most sensitive way in the world, when I was out there, they were talking about maybe nanomolar concentrations. You could determine whether there were effects on heat shock proteins, which is one of the hypotheses. And obviously, the gentleman out there who runs that facility, maybe you can help me with his name. The person I know is Chapman out there, but you've mentioned another name, Casey Walker. So you have some, if you can get them to work with you, and it sounds like you have, so that's fantastic. There are some fantastic experiments you can do with high-resolution imaging and using monoenergetic X-rays to produce some outstanding X-ray CT images to look at ultrastructure damage and to look at functional changes in cells by programming those cells with specific genes. And to my understanding, they've got that gene programming stuff working, so they can certainly help you do that. So maybe they can ship you some cells or some mice that have been programmed with this particular gene, and you can expose them where you are at your college, and then ship the animals back, and they can do some imaging for you. So, but this is really out of my territory, and I applaud you in looking at this opportunity, which is a unique opportunity for Canada.
I am a little mindful of the time. We started a little late, so I know that Thomas probably has to run fairly soon. Thomas, can I give you a chance to chime in before you? I think you probably have to leave right around now, don't you?
Yeah, we may have somebody knocking at the door in a second. Frank, a lot of what you've been talking about is how little we know and just the opportunity to do some research. Cell phones are a hot topic, and it's something people are concerned about at the moment. Do you have an idea of what other, are there other sources of this kind of radiation that we're not thinking about? So we're thinking about cell phones. What's the next thing that we should be concerned about, or at least paying attention and maybe looking to focus some research on?
Okay, so this could be wrong, just as that guy said the end of physics is here. This could be totally wrong, but let me state that it is probable that the intensity, the electric field intensity, magnetic field intensity of the waves is important. The problem with cell phones is that you turn them on and you have to communicate with enough power to reach a base station. So, for example, when you're using a wireless phone in the home and you just have to communicate 10 meters, the amount of energy being generated against your head is, orders of magnitude lower than the energy needed to go through the windows of your house to reach that base station. So maybe we can get rid of this high energy in cell phones by more intelligent use of wireless communication. So wireless communication devices are producing magnetic and electric fields which are orders of magnitude lower because of the proximity we all have with wireless stuff. So maybe
I'm producing some right now.
Right.
Yeah.
So the iPad on my lap is probably not as bad as the cell phone next to my head?
Well, it depends what you're trying to communicate with. Smart cell phones, of course will up and raise the power, lower the power as needed to reach the base station. But if you were communicating with the same way you're communicating with your unit, with your computer,
iPad.
your iPad, or whatever the thing is called, then the dose is much lower. So I think there are a lot of smart ways that we want to continue to communicate. We still want to have that kind of access. We won't be able to do it perhaps in the car as we're traveling along in terms of replacing the high power. But, are you using, what are these things called that you put at your ear? I forgot the Bluetooth. The Bluetooth presumably is just communicating back to the phone, so you're presumably lowering the dose to your brain using the Bluetooth, because the Bluetooth only has to go to the cell phone, and then the cell phone has to go somewhere. So if you're having the cell phone in some other sensitive part of your body, maybe you should not have it there. But there maybe communication with a cell phone that's in this corner of your car or something like that, or on the outside. So there are many ways of reducing the power, presumably, and assuming that power is an important characteristic for any potential harm. And as I've said, I believe that the waveform, and whether it can be demodulated, and there's some evidence it can be demodulated, the waveform, intelligent selection of waveforms will be important as we discover more and more about how these devices can cause biological effects.
And just
great,
at a
thank you.
point of, thanks, Thomas, for the question. Appleby College students, how many of you own a smartphone? Raise your hands. iPhone, BlackBerry, all that kind of stuff. Yep. Okay. How many of you use some type of a tablet, like an iPad or something like that?
All of us
Yep.
students have a laptop, tablet, yeah, so everybody.
And how many of you are using Bluetooth? Bluetooth, yeah. Okay, so a number of you. So I mean, these types of issues, they affect not just our generation, but the young generation, obviously, quite tremendously. Appleby College, question back to you to follow up on a previous question or a new one, if you will. Sorry, Thomas, go ahead.
I do have to go. There's somebody at the door. I'm sorry, our connection's up.
Okay.
Frank, thank you very
Thomas.
much for your time. That's awesome.
Thank you.
Nice meeting. Great program you have.
So Appleby College, back to you to
Yeah, we have the
go ahead.
next question. We have the next question from our academic prefect. Okay.
Hello, my name is Danny, and you were mentioning earlier, you were talking about how one of the proposed or possible effects of electromagnetic radiation would be on calcium transmission and neural synapses. And I'm particularly interested in neurology, so I was wondering exactly what the supposed effect, or the way of the effect, how EM affects that transmission. So for instance, does it somehow alter the protein structure of membrane channels that let calcium to pass through, or, I mean, how exactly does, because calcium plays an important role in allowing neurotransmitters to be released from the synapse. So where in that process would an electromagnetic wave, for instance, possibly, and I understand this is suppositional theory, but where could it possibly affect or obstruct, let's say, that process? And if possible, how could we detect those, even on the biological level, if that's
So let me work backwards. I'm an So that's, of course, a very specific question and a very well-researched question, so I congratulate you on that. You can, as you know, use a number of fluorescent dyes to look at calcium concentrations. What we set up was a system that allowed us to measure calcium concentrations inside cells during exposure. So one of the pushes of our lab has been over the last 10 years is to try to make measurements during exposure. We believe this is extremely important. So first of all, the first way we did this was to build a system that would look at, in this particular case, we looked at human transformed leukemia cell line, an HL60 cell line, and we kept them in suspension instead of using a magnetic stirrer, which obviously produced magnetic fields. We developed special stirrers which did not require magnetic stirring. And then we used a fluorescent dye. You can use Fura 2. We used Indo 1. And we loaded the cells, and then we exposed them and looked to see if the calcium concentrations, the free calcium, in this particular case, with this technique, you're looking at the amount of the active calcium compound and whether calcium is being dumped by the endoplasmic reticulum or being dumped by other calcium stores. So those kinds of experiments you might even be able to do in our lab if you wanted to. We'd have to hook up our lab to do RF work. Most of my work, as I said, been at low frequencies because that's where my interest is, because that's where the body communicates at, and that's where the greatest potential for benefit is. But you'd have to design some RF exposure systems, and then during exposure we could start looking at whether there are effects on calcium communication. So that's the experiment to be done, and us and a couple of other labs in the world can do that. In terms of what's going on if the calcium channel's being affected, so you said you're interested in neurology, so you're probably interested in voltage-gated channels, and channels that are going to be affected by voltages across the membrane. And if you've done a calculation, the voltages seem to be extremely small, so unlikely to have an effect. But we don't know. We don't know. I mean, I'll give you an example of what we don't know, and this is a crazy way of answering your question. You know, it's well recognized now that some animals can use the Earth's magnetic field to orient themselves. And some very careful experiments published in Nature and very good journals have shown you can interrupt that sense, that sixth sense, by exposing animals to RF radiation, not maybe up but in the megahertz range. Now, people have various mechanisms for how this can happen. So when you talk about mechanisms, you talk about a two-stage process. You talk about how the electromagnetic radiation is transduced to some electrochemical radiation that can be recognized, or electrochemical signal that can be recognized by the body. And then just because the body can sense it doesn't mean there's going to be a response. There's all sorts of mechanisms within the cell to damp out any perturbation. And so the whole thing is, you're looking way at the end. We're going to look at the calcium concentration. But earlier on in the process is the actual mechanism by which, some antenna converts the waves in the air to something that the body can recognize. So there are a number of theories about how that initial mechanism comes about, and then what happens afterwards, what the cascade of events are to result in a finally measurable phenomenon. And so when you ask about mechanisms, you're talking about how we proceed. So let me get back to this bird problem. It's well established that birds can sense small changes in the Earth's magnetic field. So the Earth's magnetic field, what is it? It's a half a Gauss, and they can sense, fractions of milligauss, tens of milligauss. They can sense. How is that done? According to all the chemistry we know, everything else, it's not possible. And so I brought a paper with me that was recently published on this subject because I read it on the weekend. It's in Physical Review Letters. It's the top physics journal in the world, and it concludes at the end, if I can read it, this conclusion that these effects can occur and what they imply in terms of the body's ability to isolate chemical reactions from thermodynamic effects. This conclusion is starkly at variance with the view that life is too warm and wet for such quantum phenomena to endure. So the analysis says that the implication of this very good data is a revolution in terms of understanding how effects occur at the tissue level and whether there can be quantum effects at the tissue level. So when you talk about what the mechanism is, it's not a very simple question, because we still don't know the initial transduction mechanism. It could be a simple induced current, for example. And then what is the effect on the channel, whether it's a voltage-gated channel or not a voltage-gated channel? And then, of course, the cascade of events that allow us to see something. So many things could be happening early on which we never see because we're looking so far down the pipe. But if you're interested in this area, you're going to have to struggle with a lot of people who are naysayers who say that nothing is happening. And you're going to have to develop some very sensitive techniques to measure very minute changes. And then people are going to ask you whether, even if you do measure these changes, whether they're of any importance. But I encourage you in these kinds of questions, and I really don't have a definitive answer for you because I don't think there is one.
Thank you, Appleby, for the question, though. We're talking with Dr. Frank Prato from the University of Western Ontario. Colin, as I sit here and I listen to these questions and the answers being provided, isn't this is fantastic. We're talking to the future potential scientists, of Canada and beyond, and of course the expertise that we have currently in the system. And I got to think, from an educational perspective, from your perspective, isn't this what it's all about, getting this information right down to the grades?
Well, it's interesting. I've been sitting here thinking, sort of, where do we go from here? And I think some of the students there are saying the same things. Okay, we know some things. We're now learning what we don't know, but now what? What do we do? And I think Frank's offered some really good insights into the things that we may need to know, but that they may or may not be of importance, which is really, really important to keep in mind, right? That we don't know what we don't know until we go and look for it. So I think that's just really interesting.
I think we have time for one more question from Appleby, if that's all right with everyone.
The next question will come from Matthew John. Actually, this was our focus question was his original question, so he has an extended question now.
Well, my name is Matt, and it's a follow-up question to Danny's question. So it is, are bonds in the protein structure broken or transformed when exposed to particular? So are bonds in the protein structure broken or transformed when exposed to particular electromagnetic waves? And also, we would like to know if, to the molecular level, if the effect of electromagnetic radiation on a DNA molecule could possibly result in mutation if it is strong enough.
Okay, it's a well-posed question. It's a well-posed question. So let me back off just a little bit. First of all, to break a covalent bond directly, you probably know you need about 4 electron volts. And if you calculate the energy in a quantum of microwave radiation, you know it's, I haven't done the calculation today, so what is it, 6, 8 orders of magnitude too low. And so that was the point of me starting out with this Scientific American statement, that because the energy is too low to cause a breaking of a covalent bond, there can't be any effect. Now, to me, this is written by someone who's poorly educated and arrogant in the sense that they think that all the scientists working in this area don't understand that simple statement. Sure, we understand that statement. Now, let's go beyond this. Let's look at ionizing radiation. We know that ionizing radiation can break covalent bonds and can cause single and double strand breaks directly. But much of the damage done by ionizing radiation is not the direct breaking of those bonds, but the indirect, but the creation of free radicals, which then react with the DNA backbone. So there's indirect effects. Now, with non-ionizing radiation, is there a potential to damage the DNA or change a protein structure indirectly, just like there is a potential for damaging DNA without direct strand breaks when using ionizing radiation? So that is the question, and some people argue, based on various mechanisms, that indirectly proteins can be affected. So, for example, there is a theory out there that a combination of non-ionizing fields, so prescribed, will change the binding of calcium in the big protein calmodulin. And that calmodulin usually in an active form binds about 4 calcium ions. And the argument is, and the mathematical theory holds, that certain combinations of fields can affect the potential well in which the calcium ions reside. The problem is it's always been poo-pooed because of thermal noise. But I've just argued with you that, we don't understand all that stuff. And there's very good literature which suggests we definitely don't understand it. So, if calcium binding is affected by changes the potential well of calmodulin, then the calmodulin molecule, the protein, changes its shape. As you probably know, there's nitric oxide syntases which are calcium calmodulin dependent. And so the ability to produce nitric oxide and cause vasodilation, vasoconstriction, etc., could be tied to exposures to non-ionizing electromagnetic radiation. And there's some literature which supports these kinds of phenomena occurring. So, sure, but not directly and not in a simplistic way where you insult the scientist, not you, but the author of this little page in Scientific American insults the very brilliant scientists around the world trying to address this very difficult question. So it's not going to be a direct effect because there's not enough energy in a quantum. But there are other effects, right? There's thermal heating, and then there's non-thermal potential effects. And there's some evidence that these things occur. And what we need to do is look and seek theoretical reasons that we can expand our knowledge, just like we're doing it in cosmology to understand, dark energy, dark mass. We're trying to expand our knowledge there and go beyond what we actually know. And I think that's also needed in the understanding of how physical phenomena like microwave radiation affects biological systems.
Thanks for the answer, Dr. Prato. Thank you, Appleby, for the question. We are, unfortunately, way over time for today's show. I think it's the longest show we've ever done, Colin? But it's been quite interesting.
I was thinking that too. Yeah.
So we
It's been great.
We do need to bring it to a conclusion, but I'm going to suggest something, and I'll ask you, Dr. Prato. I'm sensing that Appleby probably has some follow-up questions, probably some other questions that we haven't had time to get to today, and if they would post those online on the VROC website in the show forum, would you be willing to go and help address some of those questions?
I will do my best. I get too many emails ready, but you'll get answers. They may come from more intelligent graduate students than myself, or some younger colleagues, some former graduate students. But I will guarantee to answer all your questions, or have someone with the information answer your questions. How's that?
Thank you very much. We appreciate that. And Appleby College, any last comments before we sign off for today?
I think, yeah, Stephen Murray will be doing the last lecture.
We just wanted to thank you guys on behalf of the Science Club for taking your obviously very busy schedule to enlighten us about our topic and further our interest into our research project on electromagnetic radiation. And just on behalf of all of us, one more time, we'd like to thank you.
Thank you very much for your Thank you very much for your enthusiasm, and good luck with your future careers, and try to stay in science. We need you as a society.
Thank you very much, Appleby College, and extend the appreciation. I know I speak on behalf of Colin Jagoe from the Kawartha Pioneers District School. Thank you, Dr. Prato, for joining us here today. And that's another episode in This Week in Science and Education. Thanks to everyone for being involved. We'll see you again same time next week. Have a good week, everyone.